All right, so this is Wednesday's aim. Let's skip down to these two problems. Let's do these. Let's look at these first. It says find the missing angle measurements. If I'm finding the missing angle measurement, the angle that they want is angle X, and so that's where my little man's going to go. And what is 16 in relationship to little man? Opposite. What about 10? Adjacent. And so which trig function are we going to use? Tangent. Good. So tangent of, now the problem here is I don't have an angle measurement. So inside of tangent, we'll go X equals the opposite side is 16 over the adjacent side is 10. If you don't know your trig ratios yet, you need to know them. And by trig ratios, I mean SOHCAHTOA. All right. From here, what's the issue? The variable's inside the parentheses. What are we going to have to undo to get to X? What's bothering X? Tangent. But I've recently told you that tangent and X are like married, right? Like you can't just like pull them apart. Yeah. So the way that we undo a trig function, so let's think back to like 8th grade, Algebra 1. How do you undo addition? Subtraction. How do you undo multiplication? Division. How do you undo a square? Square root. All of those are what kind of operations? Inverse operations. And so to undo tangent, which is a trig function, we're going to use inverse trig functions. And inverse trig functions are what you see on the right side here. So sine to the -1, that's not a power. That's the inverse sine or sine inverse. Same thing here, cosine to the -1. We don't want to say cosine to the -1. That's not what it is. It's the inverse of cosine or cosine inverse. And then you've got tangent inverse. Okay, so we're learning inverses because sometimes we want to know the sides, like yesterday, and you could just go tangent of whatever angle measurement you have. Here, today, we want to know the angle measurement. So trig functions help you find side length measurements, like we did yesterday. Today is new because inverse trig functions help you find angle measurements. Really, if you set up your trig ratio, you're going to know what to do when you have X on the inside of a trig function. Then you're going to say, oh, I got to undo that trig function. Let's use the inverse. But trig functions help you find side lengths. Inverse trig functions will help you find angle measurements. So going back to our problem, if we want to undo tangent, we want to apply tangent inverse to both sides. So you're going to have tangent that looks like it's to the -1 power. Of the left side is tangent of X equals what you do to one side, you have to do to the other. So we're going to have tangent inverse of 16 over 10. So we're just taking tangent inverse of both sides. It does have to go in the front. You can't just like, a lot of people in years past have done this. That's not appropriate. That's not okay. So we don't put it after, we put it before because it's a function of whatever you have on the inside. But just like all those inverse operations we did before, they undo the trig function that's in front of X. So tangent inverse and tangent undo each other. And on the left side, we're just left with X. On the right side, that's what we're going to type into our calculator. So this is going to be our calculator stuff. So when you're ready, get your calculator, and I'll show you how to get there. Notice I could have simplified 16 over 10 before I did this. That'd just be more work on me, because what I'm going to end up doing is typing it in a calculator anyways. So that's why I didn't simplify 16 over 10. To type in tangent inverse, it's going to be the same button you use for tangent, except it's going to be second before you get there. So go second, and then tangent. And on the inside of tangent inverse, you'll have 16 divided by 10, and you do need to close the parentheses after that. If you don't close the parentheses, my fear is that it would do tangent inverse of 16. Find that and then divide by 10, and that's not what you want. Okay? Questions so far? Press enter. Does yours match mine? Why not?
No.
Why not?
Yours is
Mine's in radians. So notice in the new calculators, you see radian at the top. I didn't put mine in degrees, so I'm going to go back and put mine in degrees. And then if you want to do what you just did just one more time, you can go second enter. and enter. Now that's appropriate. Hey, what did we just find? What is x? Okay, what kind of thing is x? Degrees, right? We normally only see whole number angle measurements. We don't round angle measurements to 3 places. We round them to a whole number. And so for this one, what would it round to? 58 degrees. And so on our aims, we've got x equals 58. Oh, I still got my highlighter. 58 degrees. Again, we round angle measurements to the whole number. That's the only thing in this class you'll round to a whole number. Side lengths to 3 places, measurements to 3 places, but angle measurements is to the whole number. Questions on that one? Yes, if I put it in the directions. Yeah, usually I'm a little bit more lenient if I don't put it on in the directions, but if I put it in the directions, like round your answers to 3 decimal places or round to the thousandths place and you don't, then I'll take points off, just for details. All right, this next one, we got x and y we're trying to find. Let's start with x. Let's put little man at x. And what is 66? Hypotenuse, good. What about 36? Opposite. And which trig function uses hypotenuse and opposite? Sine. And so we'll have sine of, what's my angle measurement? X, good. Equals, what's the ratio for sine? Opposite over hypotenuse. So opposite is 36 over hypotenuse is 66. And from there, how do I solve for x? I gotta, yes. So yes, let's call it inverse sine. So we gotta take the inverse sine of both sides. So sine, it does look like it's to the -1 power, but that's how we note our inverse functions. Sine inverse of sine of x on the left side equals what you do to one side, you have to do to the other. So sine inverse of 36 over 66. Why did we do that? Yeah, to get rid of sine. So sine inverse and sine undo each other. And that leaves me with x equals. And then all I have to do from here is type in the right side to my calculator, sine inverse of 36 over 66. So sine inverse is going to be second sine. And then 36 divided by 66, make sure to close it after that. And I got 33. Anybody else? Good. So 33 what? Degrees. Man, I keep using my highlighter. How could we find y? We could do the same thing. Yep. So let's put our little man. I'll do this one in purple. We'll have to change our little man to where y is, which changes what? Does the hypotenuse change? No. Nope. The hypotenuse doesn't change. But 36 changes to what? Adjacent. And which trig function uses adjacent and hypotenuse? Cosine. So we'll have cosine of y is equal to adjacent side is 36 divided by hypotenuse is 66. I'll give you about a minute. Try to solve this one on your own. See if you can do it. Can't we just... Yep. Give you about a minute. Try to see if you can do it. Show your work. Good. That's acceptable. So I see lots of good things happening. I see we took cosine inverse of both sides. So on the right side, you'll have cosine inverse of 36 over 66. Cosine inverse undoes cosine. And y is equal to what? 57. Hey, if you were on a test and I put this question on there, how could you make sure that you absolutely got it right? See if it adds up to 180. You already know that one of your angles is 90, so then your answers have to add up to, yes, plus the 90, right? These just have to add up to 90. 33 plus 57 is 90, so we know we got it right. Questions on that? All right, this bottom one, this one's crazy. Find the missing side lengths and angle measurements. Which side length are we missing? A and B, or AB, good. And then the angle measurements, we're missing A and we're missing B, right? All right, we know angle C. Angle C is a right angle, so that's nice. Give me ideas. How could I find side AB? Ooh, Pythagorean theorem is great. Yeah, Pythagorean theorem. Tell me why I couldn't start out using trig to find AB. Yeah, we don't have an angle measurement. So if you started using trig, you'd have to start by finding an angle measurement first and then use trig to find your side. But we don't know an angle measurement. So let's start with Pythagorean theorem. So set it up for me. Tell me what to write. 15 squared plus 18 squared is equal to what? AB squared. Don't you dare use your calculator for this. 15 squared is 225 plus 18 squared. 324 is equal to AB squared. You do have peers among you who are also in Algebra 2, and they'll tell you you need to know all 20 of your perfect squares plus all 10 of your first perfect cubes. So try not to use your calculator for those. You still need to know your perfect squares through 20. Okay. From here, actually, is it 25? I think it's 25. I think it's 25. Yeah. Anyways, 225 plus 324. Okay. 5 plus 4 is a 9. 2 plus 2 is a 4. 2 plus 3 is a 5. So 549. Yeah. Equal AB squared. 549. Do you know 25 squared? No? 625. Maybe it's 24. Is it 24? 24 squared? 4 times 4 is 16. Can't be that one. Ooh, it could be 23. Why do I say that? 3 times 3 is 9. 3 times 2 is 6. We're working with the tens place. 2 times 3 is 6. 2 times 2 is 4. Those added together will give me, nope. Right? That's not good. Okay, fine, I give in. Calculator. Hey, what are we going to do to solve for AB? Square root, yep. So square root of 549, square root of 549. Oh no. 23.431. So AB is equal to 23 point, what was it? 431, is that right? Okay. Why did we go 3 places for that? What kind of thing is AB? A side length. That's why we went 3 places. Yes.
If we have something like that on the test, like it's a decimal place, is it okay if we use a calculator to solve that?
For this, it would be appropriate because I wouldn't expect you to know the square root of 549 on your own. I tried to find it by hand because I thought maybe it was going to be able to do by hand. Now, if you had the square root of like 400, I would expect you to be able to do that. So any perfect squares through 20, if you get the square root of a perfect square that's any of your perfect squares through 20, I would expect you to know that. But this one, you're not going to know without a calculator. All right, we found AB. What do you want to find next? Which one? A, okay. Angle measurement A. Let's put little man there. What can I use to find angle A? Good. 18 is close. Opposite. 15 is adjacent. Remember, opposite is the side that little man can't touch, the one that they're looking directly at. The adjacent side is the one that they can touch with one of their little arms. What trig function am I going to use? tangent. Tangent of what goes inside? A. And use a capital here. We are very picky about angle measurements. If there's a capital letter there, it needs to be a capital letter. So tangent of capital A is equal to what? 18 over 15. And how do I solve for A? Yep, I'm going to have to use inverse tangent or tangent inverse. And so tangent inverse of tangent of A is equal to tangent inverse of 18 over 15. The purpose of using tangent inverse is to undo that tangent right there and get A by itself. And then we just need to type in tangent inverse of 18 over 15. $50? Good. 50 what? Degrees. I know that little bitty circle is like, okay, Miss B, how much do you really care about that little bitty circle? I care. Make sure to put degrees so I know that you know the angle measurement is 50 degrees. Something else you could do is put measurement of angle A in the front if you wanted to, but I'm not super picky about that. All right. The only one left is B. So if I put little man at B, what is 18 now? Adjacent and 15? Opposite. So set it up for me. Tell me what to write. Tangent of B equals what? 15 over 18. I'll give you about a minute. Try to solve that one on your own. I also learned yesterday that if you don't have a calculator, you can just Google TI-84 calculator online, and it like the first website is like great. I didn't know that. I've been using TestNav for a long time, but if you don't have a calculator, you can just Google it. TI-84 online, and then it just pops up for you. All right, I see a lot of good things. Tangent inverse of both sides, so tangent inverse of tangent of B, and then tangent inverse of 15 over 18, bless you. That undoes our tangent on the left side and leaves us with B is equal to, and what is B equal to?
40 degrees.
40 degrees. How do I know you're correct? Because 50 and 40 add up to 90. So that's how I knew you were correct without even looking. Anybody not get 40? If you didn't get 40 and you want to talk about it, make sure to flag me down. Let's talk about it at some point. Hey, we have a lot of time to work. You got about 15 minutes to work. So the front side, remember the front side of your practice is new stuff. Back side of your practice is old stuff. So if you want to work ahead, I would encourage you to work on the back pages because that's the old stuff. There is some new stuff that's going to be kind of confusing for you going forward. But as of right now, you can do both sides of day 2. So try to get day 2 practice done and get your Math Excel done. Do what? Oh, and get your Math Excel done, get that paper turned in so I can go ahead and put the score in for you. Let me know if you need anything or if you have any questions.